There are 350 different gene mutations that cause children to be born blind in the United States.
If awareness and funding do not accelerate, people with IRDs that are potentially treatable are going to face a life of darkness. When I first started working on gene therapy, I was ambitious. When I met my husband, Albert, he said, why not develop treatments for retinitis pigmentosa?
There was no treatment. They were incurable diseases.
That is a group of diseases where people go blind progressively. We began in about 1988. There was so much we didn't know.
First of all, it gives hope. Even at the beginning when we didn't know things were going to work or not, it really was important for people to know somebody's out there doing something for them.
Going forward over the decades, in 2000, we had our first home run with a dog model that was a Swedish Breed born blind, and we could reverse the blindness in this dog with gene therapy. That caught the attention of everybody with a inherited retinal blindness. And we didn't know yet whether it would work in humans, but people started paying attention and were very enthusiastic. But when it comes time to a clinical trial, the costs are exponentially increased.
So when I joined the Foundation Fighting Blindness as a CEO in 2017, it became pretty clear that there was a big problem with how do we fund all these different gene therapies that have good science, but just don't have a team or the funding behind it. Opus really sort of came together at the end of 2020, early 2021. Have been looking at some of these assets at Gene Bennett's lab and others that have been literally kicked around through different companies. And I was very frustrated. I was like, what's going on here? These are good assets. And so we were at the point at the foundation and the RD fund where we had the ability to do venture creation and actually start a company ourselves.
I knew Opus because I was at a company that was contracted to run Opus's trials. And so the Opus team hired us to run the LCA5 trial. So I knew that that drug was working. The fact that the drugs were working so well, the team was great, made me want to be a part of it. And so I got the opportunity to be a part of it through Occuphire.
We found ourselves, in need of capital, great science, a whole pipeline of assets still. And we found with Occuphire, they had a failed phase 2 in diabetic retinopathy. So they needed a pipeline, they had cash, and they had a team. And the reason why it went so smoothly is because 3 of my former employees were over there at Occuphire. So the diligence was a breeze because they already knew it inside out.
When you think about the synergy and why we brought Opus into Occuphire, is the fact that these development programs, there's 7 of them, but on top of that, they're all very compact, right? So these are programs that you can develop in a certain number of years that's much more modest, much more efficient than a lot of biotech programs.
And George, as a retinal specialist, he wanted the juice too, a chance to work on IRDs with meaningful programs and work with Gene Bennett. Once we realized that we had alignment from our boards, that this was, a perfect combination where actually 1 + 1 = 3 or 4, it went very smoothly, very quickly.
There are a couple aspects that are different than a typical biotech company for Opus Genetics. The first is the number of assets that we have. So most biotech companies have a single asset that they're working on. We have 7. And these are from places like University of Pennsylvania, Harvard, University of Florida, really well-known science, really well-done science. And so these have what I would consider a high probability of success.
We understand the science and we felt like we could actually make this work.
When I try to communicate sort of the gravity of what we're doing, just hearing these patients and what their journey was like before treatment, during the treatment period, and then after treatment, at the end of the day, that's what it's all about, right? Like all the scientific metrics, things like that, are all aimed at one thing, which is making a meaningful improvement and impact in these patients' lives.
There are now advanced stage clinical trials going on, and the data looks really promising. So no matter what, There has been hope that has been presented to all these families over the decades. And as our knowledge and technology progresses, we are actually able to say, yes, this could actually treat your disease.
Some people might think that you can't solve for 300 genes with gene therapies individually, but you got to start somewhere. And I think that that's what we're trying to solve, is that you need people to believe that you can do it. And the only way to do that is to actually do it.
The ability to give those people some vision back, that's incredibly meaningful.
If and when Opus gets the first approved therapy, it's going to be monumental for the rare disease community, because it's going to prove that you really can develop in these ultra-rare inherited retinal diseases. And if you can prove that you can do that, that means that you're at the start of the race, not at the finish, because there's so many more of these that we can be doing.
Building Opus further for the coming years just allows us to go after as many of these gene therapies as possible.
If my work allows people to move from a life of darkness to one of light and the ability to function independently, that is my legacy.
And if we continue to do our job, we'll be able to cure blindness in kids and adults, many individuals and families lead a brighter future.